All right, so today we're going to be looking at Xcode Instruments. And instruments in Xcode is a way how you can check like if you have memory leaks, if you have any like under the hood issues. So we're going to pretty much go through Apple's tutorial for it. So this is it right here. If you want to get there and find it yourself, just go to Google or whatever searching browser, Xcode Instruments, and then say tutorial. And it will be pretty much this link here. It's usually the first one, and you just click on it and you'll get there too. So I'll close that for now, and I will jump back to pretty much here, which is this screen here, the same one that we were on. And it will just explain, it's just showing you. So as we go here, it says use instruments to analyze the performance, resource usage, and the behavior of your apps. So basically you can check all the under the hood stuff, see if like hand checking for hangs and all of that. And then learn how to improve responsiveness, reduce memory usage, and analyze complex. So let's get started with the tutorial. And it says the first thing is getting started with hang analysis. So it's saying learn how to analyze hangs with instruments, and then it says before you start, take a few minutes to familiarize yourself. So we're gonna I think this is where you're kind of gonna explain the different type of things that we can do with instruments. So the first thing is the following tutorial will show you how to use instruments to find a hang in an app, analyze what's causing it to hang, and then try out various solutions to fix the problem. So I feel like instruments gets ignored a lot, even though it's a really powerful tool in Xcode, but we're gonna learn it. So through multiple iterations of recordings, analyzing data, and iterating on changes to your code, you apply fixes and ultimately end up with a working code. All right, cool. And then right now they're saying that there is a WWDC that's links to a hang video. We won't watch that right now, but you can watch it on your own time. Just click on it. And then the next thing is, before we get started, this tutorial assumes you have a basic understanding of how to read SwiftUI code and some familiarity with concurrent programming and threads, which we do. And if not, you can just check out my previous streams. We kind of touched on using some Swift concurrency. So it said the sample app code you'll download and follow uses SwiftUI to specify the user interface. However, the underlying performance issues are applicable to apps that use UIKit or AppKit in the same way. Okay, so while the sample app uses Swift concurrency, demonstrated performance issues can happen in the same way using other concurrent structs like dispatch queue. So let's read that again. So it says the sample code you download uses SwiftUI and to specify the user experience interface. We're going to be we have to download some project, and in that project, it's actually using SwiftUI for the view. And then it says, however, the underlying performance issues are applicable to apps that use. Okay, so even though the view will be built in SwiftUI, it can be handled for UIKit, apps that use UIKit or AppKit. Nice. And then we read that part already. So next thing is, if you haven't worked with Swift concurrency or are just starting to, the programming language for Swift concurrency. Not going to ignore that for now. If you haven't though, just definitely check it out. It's basically showing you like how to create API requests using Swift concurrency. Some terms you'll need to be familiar with include task, actor, main actor, as well as the concurrent thread pool. And task is really good. Let's just click on this. And basically use task heavily when you're using Swift concurrency. Okay. So let's just jump back to our tutorial though. All right, and then it says throughout this tutorial, you'll see instruments. You'll use instruments to find and analyze hang while diagnosing the problem and working on solutions in the code. So we're gonna be in the project, and I guess the project already has some hanging issue, and we're gonna use instruments to kind of find those issues and I guess fix them. So the steps you follow describe which actions to perform and where in the instruments window you can find the required information. All right, cool. All right, so the next thing is gonna say, oh yeah, and there's also another WWDC session from 2019 that we could watch, and it's called Getting Started with Instruments. So we'll probably watch that stuff in a different stream. We'll probably just watch it, pause it, and discuss as we go. Now for hangs, let's see how they describe a hangs. So to me, a hang is basically say you click a button and like it's not the action that it's supposed to perform is probably being delayed by 2, maybe 3 seconds or something like that. That's how I'd see a hang. But let's see what Apple says. So a hang is a discrete user interaction occurs when a user performs a single well-contained interaction and the screen then updates. Okay. So basically when the user hits a button and then the screen updates, it does something. So, well, that's not what a hang is. They're just explaining what a discrete user interaction is. A discrete user interaction is basically when somebody taps some button and it reacts to it. For example, a person may be tapping on a button, say a button on screen, and the button color then changes to indicate that it's pressed. So processing the interaction event is usually so quick that you can't perceive it, and the screen update seems instantaneous. Yep. So it's really fast. So when you make, say, if you add some action to a button, and the user presses it, this action happens so fast that it just seems like it happens instantaneously, but it's actually taking some time. Okay, code runs through logic really fast and just does it. So next thing it says, when there's a noticeable delay in the handling of the user interaction, that period of unresponsiveness is known as a hang. Okay, so they explained to us what a discrete user interaction is, and that's basically when you tap a button, interact with some view, and then some action happens. But now they're telling us that when there's a noticeable delay in handling the user interaction, that period of unresponsiveness is called a hang. So again, a hang is, say you press some button and that action, it doesn't happen right away. So if I press a button to see a different screen, and it takes me 2-3 seconds for that to happen, that's a hang, since it should almost be instantaneous. Like what they're mentioning here, discrete user interaction. All right, so now it says hangs are frustrating, which they are, and they shatter the illusion of directly manipulating the objects on screen and leave you wondering where the app is working currently. All they're saying is that still hangs are frustrating, and it will make you wonder why the action isn't being performed after you press the button. The next thing is they make you think about the app itself instead of the task you're performing, which in turn causes an impression of the app getting in the way. Yeah, so like when you're using an app and then you click a button and say it doesn't respond right away, I do start to think like, yo, what's happening? Is this app not good? Are there some issues? Maybe I should just quit it and go to the app store and download another one. So that's another reason why you don't want hangs in your apps. So you don't want the user thinking about, yeah, let's go to some other app or do some other and now for the next section, we say event handling and main thread and the main thread. So understand how a hang happens. It's important to know. They said it's important to know how the operating system handles events. And the main thread is an essential piece of event handling pipeline, of the event handling pipeline. Okay. So basically, all right, so to understand what hangs happen, it's important to know how the operating system handle events, and the main thread is an essential piece. So for us to understand how hangs are happening, we have to understand how Swift, the iOS is really handling how it handles when a button is interacted with, and how we are handling the main thread. Remember, the main thread is where we're supposed to use pretty much all UI updates should be done on the main threads. And then if you have some long, like some API calls or intensive, really long processes, you can just throw that on the background thread. Okay, so the next piece is understanding user responsiveness. And this is just an article, and I guess this article is going to explain. The article provides an example overview on event handling and rendering loop. You can read it on your own time, maybe not different stream will go over that, but for now, let's just jump here. So understanding hangs in your apps, and then I guess this article describes, because the main thread processes all your user input events, knowing how the main thread of your app works is essential to understanding hangs. So I guess this would be a good article to read. We'll probably read this in a different stream, but let's just click on it. And it looks like it's just describing understanding hangs in your app. Pretty much just describing what hangs are. We'll do this in a different one. I know let's skip. So we have an important notice here. And what does it say? It says to prevent noticeable delay in user input, no work on the main thread should run uninterrupted for more than 100 milliseconds. Okay, so basically they're saying any work that you're doing on the main thread shouldn't be anything that takes up a lot of time. It should be really quick, making UI updates, nothing to extent that's taking mad time. It does take time, like we mentioned, put it on a background thread. All right. So next is hang analysis strategy. So it says the first step in analyzing a hang is being able to reproduce it. So whenever you see some hang issue, like if QA, if your testers say they're clicking on a button and they're not seeing the expected reaction happen right away, the first thing you gotta do is try to reproduce it. Probably ask them for the steps that they followed to see if you can get there. And then it says as soon as you can reproduce it, analyze the hang with instruments, which you can use to identify whether a busy or a block main thread caused the hang. Okay, so once we find the issue, like QA tells us that there's an issue, we should try to reproduce it, like try and do it for cause the hang for ourselves. And then we can try to analyze it. And they're saying that it could be two issues if we're having a hang. It could be a busy main thread, or it could be a blocked main thread that caused the hang. And then it says a main thread can process incoming events a main thread that can process incoming events is called unresponsive. That makes sense. And then the two issues that they mentioned is that like a busy main thread means that your app is constantly processing data and the CPU usage is high. So that means the main thread is busy because you're doing so much work on that main thread. So it's like, so it says that your app is constantly processing data and the CPU usage is high. So you can see the CPU usage inside Xcode. I forgot which tab it is in, but you can see the CPU usage. So let's jump to the next point. So it says a block main thread is a halt in work on the main thread, resulting in operating system giving CPU access to other threads. So this one, so for our block main threads, it seems like it's saying that we're not able to do any work on the main thread. So if you look at the diagrams, you can see this one is a blocked, and this is like the main thread. We have this huge gap where no work is being done on the main thread for quite some time. And then for the busy main thread, you can see that it's a ton of work being done on the main thread, which is not what we want. So now we can tell them differently. So if it's busy, we're doing a ton of work on the main thread. And if it's blocked, we are not doing much work on the main thread. So we might be doing a ton of work on some background threads that are resulting in work not being done on the main thread for blocked. It says the CPU usage of the main thread during the hang is a good indication of whether it's busy or blocked. So knowing whether the main thread is busy or blocked determines the next step in your analysis. Okay, so yeah, so when the results are inconclusive, whatever that means, inconclusive, for example, the average CPU usage is around 50%, or goes significantly up or down over the hang duration, go with the dominant aspect first. So let's read it again. So when the results are inconclusive, for example, the average CPU usage is around 50%, or goes significantly up or down over the hang duration, go with the dominant aspect first. Okay. And then it says, for example, if the main thread has a low CPU usage, most of the time with a small spikes in between, treat that hang as a blocked main thread. Okay, so this one right here. And then it says, otherwise assume a busy main thread as those are easier to measure and analyze. So it's saying if we see like so if the main thread has a low CPU usage, most of the time with small spikes in between, like what we have here, we should treat it like what we have here with these small spikes here, and then we see this huge gap. We should treat this as a block main thread. And then if we jump back to busy main thread, it says when the cause of a hang is a busy main thread, The next step is to examine what's happening on the main thread. Okay, so if we see the main thread this busy, you're saying like, all right, let's see what type of work we're actually doing on the main thread that could pretty much cause this hang. So scroll down to more. So it says when the cause of a hang is a busy main thread, the next step is to examine what's happening on the main thread. And we have an image here, and it looks like this is the main thread, and there's a ton of work being done. And even above this, we see something that says severe hang. And then it looks like this is maybe our UI view, or I mean our Swift UI view, but let's continue. All right, so the time profiler instrument often gives us a good overview of which functions use the most CPU time. Okay, so if you want to find out which function in our app is, say, taking up a lot of time to do some work, I guess the best instrument to use for that is time profiler instrument. Okay, and so this allows you to determine where in your code to look for optimization potential. Okay, cool. And this seems like this could be a good skill to learn then, and this is why instruments are important, because you could have an app taking extra time to do a task, and like that's gonna ruin the experience for a lot of users. If you use instruments, you look like you'll be able to find out exactly where that issue is taking so much time, and maybe you can offload some of that work, or just cut down some of that work that you might be doing. All right, so there are two ways to fix that. If we have a busy main thread, it says to identify work your app doesn't need to do right now. So go look, if you find an issue where you're having a busy main thread, we can use the time profiler they're saying to find out, identify work your app doesn't need to do right now, and then see if we could do it maybe later. And then the next step is do the same work but rely on using background thread instead of the main thread. Then when the work is complete, notify the main thread. Okay, so let's look at those two again. So the first one is identify work your app doesn't need to do right now. So it looks like they're saying if we see a busy main thread and we find out where that's happening, let's look at that function or process and see if some of that work doesn't need to be done right now. Let's say if you're formatting some text and then you're updating some image. Maybe we don't need to do all of those right now. Maybe only one screen we show the text, and then next screen we're going to show the image. Let's just split up that work. And then the next point is do the same work, but rely on using background thread instead of the main thread. So if we have some long tasks, let's push it to the background thread. And then when it's done, let's jump back and update it on the main thread. And I guess what we could do to do this is like a dispatch main.async and dispatch.background, and you create like a background thread and use that for some of the work that we want to do. And when done, we just use dispatch queue.main.async and then update it on the main thread. And we see this charge here. So it says unresponsive main thread. And if it's an unresponsive main thread, like I said, you could go with the approach of doing less work. Or if it's another unresponsive main thread, you could go with the approach of moving the work to the background thread. I like Apple's diagrams. They're pretty detailed sometimes. So the next thing is like Marcus Brownlee mentions, like whenever he does like a WWDC or like a review based on like an Apple product like the MacBooks, he always complains about the charts. Like there's no way to like it's difficult to read some of Apple's charts. They won't necessarily carry in all that detail. So that's one thing that I mentioned, but I like these diagrams so far. So next thing is to determine which path is most promising. You need to determine how often specific functions execute to see whether there is unnecessary work. Okay? And then later you'll discover how to approach this decision and why Time Profiler can provide information about individual function executions. So it looks like Time Profiler actually can't provide us with the time spent by each function, which is odd because it looks like that's where they're leading, but let's continue. And now the next approach is the next issue that we could have. So we just discussed busy main thread. So the next issue that we could have is, as they mentioned, is a blocked main thread. And let's look into this. So a blocked main thread means that the thread is, a block main thread means that the thread is waiting for another entity, like another thread or process to finish performing other work or to simply free a resource it needs. So basically, you see this huge gap right here that they're saying. They're saying there might be some other work being done on some main thread. That's why the on some background thread, there might be some other work being done on a background thread. And that's why we have this huge gap on the main thread here, since we haven't come back to the main thread, since we're still doing a ton of work on those background threads. And it seems like after some time, that work on that background thread eventually ends, and then we jump back to the main thread here. Okay, so huge gap in the main thread means it's more likely blocked. And then if you see too much work, like too much of these blue here on the main thread, that means the main thread could be busy. All right, so next thing is, it says in most cases the blocking task already exists on another thread or process, while the same general concept of identifying, all right, let's do that. So in most cases the blocking task already exists on another thread or process. So that's saying the process that whatever we're doing in the app, that might be taking, maybe we're formatting some text or support, or waiting on some API call to complete. The reason why the main thread is blocked is because we're doing that huge process on a background thread, which we should be doing, but it's taking up so much time on that background thread that it's actually making that we're not getting any updates being done on the main thread. So then it says, while the same general concept of identifying what work not to do or moving work to the background applies, the work is already performed in the background. So the issue with this is, usually we'll say, all right, if we're doing too much work, let's put some on the background thread and then eventually push it back to the main thread. But with a blocked main thread issue, blocked main thread hang, we're seeing that we have work being done on the main thread, but that work is just taking up so much time that we can't even get back to using some of the CPU work being done on the main thread. So it's different for this one because we're using background threads, but that background work is taking up so much time. The next thing is, all you need to do is identify the part of the code that causes the main thread to wait on the completion block of the work on the background thread. So we have to find a way to find out where in our code is on the background thread and causing so much work to be done. So maybe we have a function making an API call, but this API call is downloading a massive set of files, or maybe we're not doing pagination and we're just pulling down a huge set of data. All right, then it says, then you can change it to not wait and have background thread notify the main thread asynchronously after the work is done. This way, you don't need to change the actual work being performed in the background. Now it says, your biggest challenge, however, is identifying the code that causes the main thread to wait. So the first thing we have to do is find out where in the code is causing the problem. Where in the code is on a background thread that's taking up so much time. And so by default, time profiler only helps you understand what the CPU is executing. The time profiler only helps us understand what the CPU is executing. But the code setting up the thread to wait might use very little CPU time. Okay. So they're saying that the code, so time profiler, which is what we're going to use, only let us understand what work is being done by the CPU. But the code setting up the thread to wait may use very little CPU time. So they're saying that like we might not be able to see it using time profiler. And then it says during the actual waiting period, the main thread is blocked. It isn't executing and it isn't using any CPU time. Okay, so during actual waiting period, the main thread is blocked. It isn't executing and it isn't using any CPU time. I remember time profiler was just saying that it's going to give us what it will be able to tell us what the CPU is executing. But however, it says for block main threads, we don't really get much CPU time. So it looks like we might have to use something else instead of time profiler, because for block main threads, again, we won't have a ton of CPU time to check, but the time profiler gives us CPU time for like how long certain processes might be working. So it says instead of using time profiler, use thread state trace instrument. So this is a new instrument, I guess they're explaining to us, and they said it can be used to analyze how long exactly the main thread is blocked. Okay, so we can use this new instrument, and that can tell us how long the main thread has been blocked, like if it's been 4 seconds or so. And it can also tell us what it's waiting for, and which part of the code makes the waiting call. So it looks like thread state trace might be the right instrument to use for this, because one, it can tell us how long the main thread has been blocked, and it can tell us what it's waiting for, like maybe which function it's waiting for, and which part of your code actually make that function call that's causing the massive wait. So definitely need to learn this then, because this is what I really want to know. So whenever I'm working on my app and say I see a hang happening, which is some delay in some action that we are expecting, it look like we can use thread state trace so that I could find out how long that hang is. So if it's 2-3 seconds or whatever, or I think it probably will be in milliseconds here, but we'll see. Or, no, probably seconds, so that they don't have to do that whole thousands. Anyway, so we can find out how long that blocking has been, and we can find out where, like, which function might have been causing that issue. The next, it says the subsequent chapter only covers examples for a busy main thread, not for a blocked main thread. To learn how to use thread state trace instruments, find out what blocks the main thread, watch this WWDC. So it looked like our instruments tutorial here today will pretty much just be handling we'll just be checking for busy main threads. We won't do one for block main threads. So our testing is gonna pretty much look most of the times like this, like a busy main thread. First is this one, a block main thread with a huge gap here. So it looks like we're done with this chapter, and we're gonna get pushed to the next chapter. So the next chapter is gonna be identifying a hang. And it says this tutorial guides you through recognizing a hang, using instruments to record it, and to determine whether the hang is the result of a busy or block main thread. I don't know why they even asked this, since they just told us that we are only going to be looking into busy main threads here, where it says subsequent chapter only covers examples of busy main threads, not for block main thread. But anyways, it still mentions it. So in the next stream, we're gonna kind of go over this next chapter, and this is where we're gonna discuss how to use instruments to really find where the main thread is being blocked in our code. So stay tuned, and we'll jump to the next chapter.